Hello dear subscribers and watchers, what's up? It's me, Saidalia here as her from Computer Science for Self Doubt. And in this video, I'm gonna talk about the most important and most crazy topic that people have been requested me all the time, and that is multitasking or multi-threading in Android. So if you guys find this video a little confusing or something, well, bear with me. We will be talking about this with the help of real example in the next video and when we work things out. For now, just try to understand what's going on basically. First, we will have a brief discussion over what is multitasking in Android, how many types of multitasking do we have that can we make a multi-threaded app in Android. Then we will dig further and we will be talking about thread and async tasks in Android. So these are the contents that I have provided for you guys, so that I'm gonna teach you in sequential order so that you can understand clearly what are multitasking and what are their differences with threads, handlers, and other things. First, what is multitasking? Execution of multiple tasks simultaneously is the concept of multitasking. It means if you want to create a program that can do different things, like downloading while you're opening your app can download some files from the internet or some background change. So that is the concept of multitasking. The Earth can be the best example of multitasking, because if you consider the planet Earth as a process or as an application, if you go inside this planet, you will discover that there are different creatures or human beings. Each of these, in the term of computer science, can be considered as a thread. While you're walking on the street, you can see birds are flying above your head, airplanes are hovering over you, and the cars are passing just beside you. So this is what multitasking is all about. We have two types of multitasking, which are as follows: process-based and thread-based multitasking. Let's talk about process-based multitasking. Execution of several tasks simultaneously where each task is a separate process. Such type of multitasking is called process-based multitasking. While thread-based multitasking, execution of several tasks where each task is a separate independent part of a same program. Such type of multitasking is called thread-based multitasking. Process-based multitasking is best suitable at OS level, and thread-based multitasking is best suitable at programmatic level. You have to know that the main objective of multitasking is to reduce response time and to improve performance of the system. As I've told you earlier, process-based multitasking best suitable at OS level because in the OS level, for every process, separate address space is there. So here, context switching between thread is costly, while the thread-based multitasking best suitable at programmatic level. All threads work in the same address space. Context switching between threads is not costly as it is compared to process-based multitasking. So now we are gonna talk about threads in Android. Well, multi-threading is one of the most valued concepts in any programming language. Making adept use of threads on Android can help you boost your app's performance and reduce its response time. When a user opens an application, Android creates its own Linux process, and besides this, the system creates a thread of execution for that application, which we will call them as main thread or UI thread. And this main thread is nothing but a handler thread. The main thread is responsible for handling events from all over the app, like callbacks associated with the lifecycle information, or callbacks from input events, or handling events from other apps, or refreshing the current activity which users are in. In a short sentence, we can say it is a thread is nothing but it is a flow of execution. It is an independent path of execution in a running program. And you also know that codes are executed line by line in a program, and these lines of course are compiled by a thread, which is called main thread or thread of execution. All apps that you will create on Android phones are using Java threads, and it has a thread called main thread, and it is responsible for handling or for showing the UI on the screen, and it is also responsible to respond to user actions by handling events. If I demonstrate a real example in a Word program, you will see how a thread works. So I'm gonna pause the video so you can see a real example of thread in real life. As you can see, the Word program is a multi-threaded program. For example, while you're typing, it also corrects your mistake. Who is the person who corrects your mistake? That is nothing but a thread. For example, if I write I were human, at the moment you press enter, you see that there is a grammatical error, and it says that you should use was in here. So this is what threads are doing. And again, the next example, if I write she love you, if I press enter again, it tells you that it is not correct in grammatical way. So you have to choose she loves you. So this is how threads are working. While you're typing, it also corrects your mistakes. So I hope I have made you crystal clear with a real example in a Word program. Let's jump to our presentation and let's dig further what I can teach you. So this is a thing that I'm gonna illustrate you through a real example. Each thread has a message queue and a looper. A looper is used to take one task from message queue and execute it. Whenever a broadcast receiver, activity, or service providers want to execute something or execute any task on the UI thread, so they're gonna ask the looper to execute them. But they will drop their tasks or messages inside the message queue, so the looper can execute them one after another inside the message queue. For example, the broadcast receiver will tell the looper, hey looper or main thread, I have a task and you need to run it immediately or execute it immediately. And the looper will say, well, put it on the front desk. If I get free time, I will execute that for you. And again, when that activity wants to execute something, it tells the UI thread, okay UI, I have some task and you need to execute it right now for me. And the looper will say, or the main thread, put it on the front desk. If I get free time, I will execute that for you. And also, service has a message to execute on the UI thread or main thread. And again, looper will say, put it on the front desk. If I get free time, I will execute that for you. But the content provider runs asynchronously, which means it threatens the main thread, I have an urgent issue or an urgent task and you need to execute it right now. And the looper will not say that, put it on the front desk and I will execute that for you. Because content providers have higher priority than broadcast activity and service providers. And the looper will execute the task of content provider immediately. And after that, if the looper or main thread have got enough time, it will come and check the message queue and will execute one task one after another. So you have to make sure that you do not block the UI thread, because every time it is the responsibility of the UI thread to update the screen every 16 milliseconds, and the UI thread has 16 milliseconds to do all of its work. If the task takes too long, your application will stutter and a dialog will appear and will tell you application not responding. And there are two options that you have to choose once: wait or close. If you look in this scenario, your current thread will updating the screen, and if there is a process of your app which requires to do something and it takes 4 or 5 seconds, so there will be no issue. But if that process inside your app takes too much time and the current thread will not update the screen, so this is where you get a dialog which appears, application not responding. So this is how, if you block the UI, this is the scenario you will get, and this is called as ANR, application not responding. You have two options: either you click wait, so that you will be waiting till the UI thread gets back to work, or close it. So this is why I've told you earlier, if the UI waits too long for an operation to finish, it becomes unresponsive and the framework shows an application not responding dialog. So what are long-running tasks? Long-running tasks are nothing but they are network operations, long calculation, which take a lot of time and block the main thread, downloading or uploading files, processing image, and loading data from the database. So these are all the long running operations which you must not run them on the UI thread. You have to create a separate thread for them, and you have to do all of these things in the background and give it to a worker thread or a background thread. So you have to execute long running operations on the background thread, okay? And there are certain frameworks that you can use, like async task, loader framework, and services. And we will talk about these three also in the upcoming tutorial. But I highly recommend you, if you have a task which takes longer than 5 or 6 seconds or 20 seconds, make sure that you use the services, because it has higher priority. So this is your main thread, and it is responsible for updating the UI. And if there is a task which takes too much time, so you have to create a separate thread and give it to that thread to execute the task for you when the task finished. So this will tell the UI thread to update the UI. So the worker thread or background thread will put its message or task inside the message queue of the main thread, and the main thread has a looper which executes those tasks one by one. And you cannot update the UI from the background thread. So there are certain methods that you need to call from the background thread to transfer the control to the UI thread to update or do something for you. This is the architecture of thread in Android. So if there is a task which takes too much time, so you have to create a separate thread, okay? And this thread will send a message to the main thread and put its message inside the message queue of the main thread. And you cannot send a message directly to the main thread and put it inside the message queue of the main thread. You have to use the handler. So the handler will be responsible to send your message to the main thread, and the main thread will execute that from the message queue. And then the looper will execute each task one after another, and it will take one task and give it to the handler, and the handler will handle your message. And at the same time, you can also send message using handler to the main thread and put your task inside the main thread message queue. So you have to remember one thing, that you cannot update the UI from the background thread, as we will work out a demo on it, okay? If you want to update the UI, make sure that you use the handler reference, and we will also create an object of handler how to send message and put your task or put your message inside the main thread message queue, okay? So if you guys find this life cycle a little confusing or something, well, bear with me. I will be talking about this with the help of real example in the next video. So this is another example of the thread architecture, okay? So this is a thread structure. Each thread has a message queue and a looper and a handler. The message queue is nothing but it is where you drop your messages. The activity, the service, and broadcast receivers put or send their messages inside the message queue, and then the looper will execute each message and give it to the handler, and the handler will handle the messages or the task which has been given to it by the looper. And at the same time, you can also send message inside the message queue also. As you can see, we have runnable and message. We will also talk about what is message and runnable, okay? As you will see a real example that you will send some work or task inside the runnable object by using the handler. And you can also put message inside the message queue by using a message object. Well, first, what is message? A message is nothing but it is containing a description, an arbitrary data object that can be sent to a handler. As you know that the constructor of the message class is public, and the best way to get one of these is to call message.obtain, and it will pull them from a pool of recycled objects. And make sure that you initialize it inside your background thread or any task or any thread that you want to get with the UI. So this is one of the ways that you can communicate with the UI from the background thread. From the background thread, you ask the UI to do something by sending some message with using message class. So there are certain methods, and the descriptions are also given in here. You can pause the video and read all of them, okay? You can also send message. You can also send message at the front of queue, as I've already told you in here, okay? At the front of queue and the middle of queue, and send message at a time, send message by delay, and sending an empty message. And processing these message, handler needs to implement the handle message, which will be called with each message that appears on the message queue. There, the handler can update the UI as needed. So there are two rules for Android threads when you want to create a multi-threaded app for your Android phone. First, do not block the UI thread, so you must complete all of your work in less than 16 milliseconds for each activity. The main thread in Android will be responsible to update the UI in 16 minutes for each screen. And make sure that you use a background thread for a task which takes longer than 16 milliseconds. Operations on the non-UI work on a non-UI thread. And you must not access the Android UI toolkit from the outside of the UI thread. Do all of the UI work only on the UI thread. And if there is a task which takes longer, so you must create a separate thread for it. So these are the challenges that you will be faced by using threads in Android. Main thread should be available to handle events from different views and components, because it is the responsibility of Activity Manager and Window Manager to monitor the app for their responsiveness. It takes more than 5 seconds on the main thread for an activity, ANR error is triggered, as I've shown you earlier. A dialog will be created and it tells that Android application is not responding. So another challenge is their priority. I mean the thread priority. While you're using or while you're interacting with the Android app, user may switch to a different app while performing a task that takes a long time. And Android terminates processes to free resources when they are not used anymore by that activity. The process being used by the user currently has the highest priority and is always the last to be terminated. As you can see in this dialog, there are several processes with their priority. The current process or the active process I mean, while you're interacting with your app, it is called as an active process and it has critical priority, which means the highest priority. And another processes are visible processes and starter service processes, they have the higher priority. And the background processes and empty processes have lower priority, which means if the Android run out of resources, it will terminate these processes to free some resources. Threads inside an activity process are only important to that activity, so bear that in mind. If the user moves away from the process, its trace may also be terminated. The thread is important only as long as the process within which it runs is important. So this brings us to the end of this particular tutorial. And in this video, I've given you guys a rough overview of what is multi-threading in Android. In the next video, I'm gonna dig further and show the technical architecture of threading in Android and how we can use the threads in our applications with certain methods. And of course, after that, we are gonna work out a nice example that downloads something from the internet using threads, which is a long operation and it takes a long time, and we do that by using a separate thread or a background thread. So if you guys find this video a little confusing or something, well, bear with me. We will be talking about this with the help of real example in the next video when we work things out. For now, just try to understand what's going on basically, and support my efforts on my channel by watching my videos through YouTube and in any other ways you can, so I can make many more tutorials on many different subjects. And if you have any questions or suggestions, just let me know in the comment boxes below this video and I will answer them ASAP. Have fun learning. Peace out.